What have we done until now? We started with basic ASA configurations, right? We did routing on the ASA. We did redistribution of routing protocols, right? What else? We started with NATing on 8.2. We didn't go through 8.4 yet, right? So on 8.2 we did dynamic NAT, dynamic PAT, then we did the combo, then we did NAT control. With it we did identity NAT and NAT exemption. Both are the same thing but a little different, right? Then we moved to static NAT. First static NAT, which was also our source NAT. Then we moved to destination NAT. Then we started with policy NAT, and also along the way we also did static PAT. So that was until yesterday, right? This is the first module that we have done. The other one that we are going to do today, this is basic configurations and NAT. The next one that we are going to start is redundancy on the firewall. Now which kind of redundancy are we talking about? There are different kinds. One is interface level redundancy. Then we also have ISP level redundancy on the ISP's level. If the ISP goes down, how does the firewall react, right? And along the same lines we have ISP interface, then we have box level redundancy. If a firewall box goes down, how do we manage our situation in that case? Then along box we have active standby, we have context, in context we have active. This concept is also called, the box level redundancy is also called failover, which comes under two categories: active standby and active. Today we'll try to finish from here, from interface until failover, active standby. Alright, this part is a little complicated, which requires this as the base. So we'll build the base today and then we'll build on it on Tuesday or Monday, we'll see. Okay, let's try to do that. Let's start with interface level redundancy, right? Now what is meant by interface redundancy? I have a firewall which is connected usually to a switch. Usually when I have a device like a router on a firewall or a firewall, we don't connect it directly to the network, we connect it to the switch, and the switch is connected to your network. Yes, from outside you'll have one connection of the internet, which will be your default gateway going out, but inside you connect it to a switch. Everything is fine. What happens is, sometimes, maybe that might not happen a lot of times, maybe once in a while, this port on the firewall might go down. This port on the firewall might go down, so there may be a problem communicating through this link. If that is the case, if that happens, what we can do on the firewall is we can have another link which will be connecting to the same, it will be connecting the firewall to the same place where it was before, same VLAN, same everything, But the only one thing is that this will be active, this will be standby, passive, not doing anything. But the moment this goes down, this comes up. Now there's a couple of concepts you have to think about here. The most important being, see, this is active, right? And this is not active. How to bundle them together? We bundle them together by using this, not ether channel, it's called redundant interface. Just like you have interface port channel, you also have interface redundant. This was introduced in iOS 8.2 and above. Redundant. You can have as many as 8 redundant interfaces on a firewall. So basically what you do is you create this interface redundant, then you assign which interfaces do you want to make part of this one redundant interface. Then whatever policies or whatever else you have to do, where do you do it? On the redundant interface. Nothing else, on the redundant interface. Is that clear?
Same as multi-home.
We do it in the BGP. On BGP, multi-home, you have 2 links coming in. So one goes down, the other comes up. This is different. This is on the firewall, locally on the firewall. Locally on the firewall. So you have ports, one goes down, the other comes up. It's not ISP level. Obviously this side goes down, firewall will not know it's going down. Right? In that case, no. But this is the most basic form of redundancy that you have. The most basic. Yeah? Good? Let's move. Let's create a simple topology to do this. Pretty simple. I'll get a router from here. Another router. So one will be up here, the other will be up here. Between them will be a firewall. PICs, we'll use PICs. But it won't be connected directly, it will be connected through a switch. Now this side you can't help it, but this side you can. E1 and this will be E2. So E1, E2 are completing. E1, E2 are combining together. Now only one of them will be active. Both can't be, obviously. You can't have 2 interfaces having the same IP address. Right? So one of the 2 will be active. We'll see which one. E3 we will connect it to R2. Right? So we have something like this. Remember, this is what? E1 and E2. This is E3. Let's do the basic configuration on R1 and R2. This is going to be 10.11.11.0/24. This 20.0/24. Good? Ten, 11.11.1. No shut. 10. Right? Just a default gateway pointing towards 10.11.11.10. Then again. Is it clear? Can you see it properly? 20.2. No shut with the default gateway pointing towards the firewall. 20 dot. Good. So let's try now. On the firewall, my configuration is left where? On the firewall. This is E1, E2, E3 again. Let's go. First configure E3. Enable conf t hostname ASA interface Ethernet 3 IP addresses 20.10. No shut. Name if outside. Can I ping? I should be able to. Now from above, from this side, I have two physical interfaces. I need to map them together as one. First things first, if you remember, whatever virtual links we create, the first thing that we always have to do is go to the physical interface and bring it up. So the no shut command should be given to the physical interface first. Then you can move further. So let's go do that. Interface Ethernet 1 no shut. Interface Ethernet 2 right? No shut. That is the first thing that you do, always. Now both of them are physically up. Everything else should be done somewhere else. We'll see where. Just like you create port channels, interface port channel, you have interface redundant. Then you have 8 redundant interface numbers that you can choose for. I'll choose one right now, that's all. Just one and enter. Right? There you used to assign it as a part of ether channels. Here you just say member interface. What is the member interface I have? Ethernet 1. And what does this say? Security level and IP address are cleared on Ethernet 1 and Ethernet 2. Let's check them out. Show run interface 1 and 2. Right? It's cleared. It's no shut, but there's nothing else on it. No name if, no IP address, no security level. And you can't configure it because it's part of the redundant group. Let's go in there. Interface, not Ethernet. Now whatever configuration I have to do from now, where do I do it? On the redundant interface. Nowhere else on the redundant interface. So IP address is 10, 11, 11, 10. No shut, no need, it's already done. Name if, inside. Security level 100, set already. Good. Let's see if this works. I can ping, right? Can R1 reach 1.20.2? What is 1.20.2? R2. R1 can reach R2 through the firewall, right? So out of these two links, one of them is active. How to check which one? The first one that you put in there becomes active. Ethernet 1. Show interface. Show interface. Show interface. I'm on the wrong device. This is your redundant interface. Which one is active? Ethernet 1. You have everything else is the same. But what I want you to see, this is the IP address, how many packets went in through, how many CRCs, a lot of other things, right? The important thing is this. MAC address. There's a question I want to ask you, right? Now, redundant interface is using which MAC address? Where do you think he took this MAC address from? Ethernet 1. Let's check. This one ends with C401. Ethernet 1 has C401. Let's check Ethernet 2. Ethernet 2 is C402. C402. Now let's do one thing. I'll go to this guy. I'll say Ethernet 0. Ethernet 1, I'll shut him down. I'll shut him down. My ping will work. Will it? What MAC address do you think the redundant interface has now? C4. How does it work? Explain it to me on the switch.
The कैम टेबल है उसकी ऑलरेडी बिल्ट.
Cam table is physical address.
Yes.
The cam table is based on physical address. वो पोर्ट नंबर पे मैप करता है, बट नाउ द पोर्ट नंबर चेंजेस. Cam table was saying 401 is from this interface. But when this went down, the MAC address is still which one? The same, and it's bound to which port? This port number. So when the packet comes in, he'll still forward it where? To the old port number, क्योंकि इसने MAC address अपना change नहीं किया. The MAC address was still the same as Ethernet 1. How does that work? Now he's using this interface, right? इस interface का physically अपना address C402. The physical address of this interface is C402. But the redundant interface that is working right now is using C401. Active ही है ना इस वक्त. Physically क्या है इसका? C402.
जिससे पहले मुझे दोनों
यूज तो वही हो रहा है ना. It's right now it's using C401.
सर मेरे ख्याल से जब हम ये रिडंडेंट ये बनाते हैं, ग्रुपिंग करते हैं, तो उस टाइम जो एक्टिव इंटरफेस था वो सिर्फ उसका ही आईपी लेता.
IP means
Sorry,
MAC.
MAC लेता.
वो तो ले रहा है ना, वो तो ले रहा है, वही तो मेरा क्वेश्चन है. वो ले रहा है, उसके आगे क्या होता है? राइट नाउ व्हाट इज द एक्टिव मैक? C401. बट फिजिकली कौन सी इंटरफेस आप है?
402
402 आप है. 402 का फिजिकल 402 है, वर्चुअल 401.
maybe it assigns that map to that redundant interface.
Which Mac? C402?
The first-
The first address is assigned to the virtual. The first assigned ही होता है. But what I'm saying is physically वो down हो गया ना एक. Physically which one is up? C402.
तो
02 is up.
उसका वो ईथरनेट फ्रेमिंग दोबारा से करता हूँ और उसमें वही मैक एड्रेस डालता हूँ.
कौन सा वाला?
पहले वाला जो लिंक था
कौन डालेगा?
स्विच डालता.
See, the switch does not do any framing. The packet comes in from here.
Yes.
The packet comes in from here. The destination, सुनो बात सुनो. The packet comes in from here. The destination MAC,
Was 401.
English bolo. Yeah, he doesn't understand your language. Speak in English. So what I was saying is the destination MAC from here comes to what? 3401. Packet reaches where? The switch. The switch has two ports. This one is mapped with C401. This one is mapped with C402 because physically both of them will be mapped. Just like अभी तक हम वैसे ही पढ़ते आ रहे थे ना, physical mapping with the, until now that's how we used to do it. So when the packet reaches here, the destination is C401. So physically he should always forward it where? To this interface. Even when the switch was made, this interface it didn't go down from this side, it went down from this side. So when the packet comes in, it goes where? It still goes this side. But abhi ping ho raha hai. How is that happening now? You have to understand the fact that since they are part of the redundant interface, right? They don't take part as their own. They don't take part physically now. They lose themselves completely. They lose everything. They don't even use their MAC addresses anymore. The only MAC address that is used is the one which the redundant interface assigns. That's what you said? The redundant interface that the MAC address that is assigned is that. So if this is active, he'll reply for 401. When it shuts down, this comes active, right? And he sends out a packet, he sends out a packet for 401, right? But what happens here is 401 कौन represent कर रहा है? This link. 402 कोई represent करता है? No one shows 402. 402 is never seen on the switch. If it was a physical interface, 402 would have been there because this interface would have replied to the app, or this interface would have replied to the app. But who's replying to the app? The redundant interface. He's replying with what? He's replying with this MAC address always. Be it on this active, be it on this active. Be it this is active, he'll always reply with the same MAC address. Do you get it? Confusion? Yes? समझ आया?
Even if you will have an 8 redundant,
He'll use one.
same. Same.
One MAC address.
Which one was initially
The first
activated?
one which is assigned
Okay.
will be used always. Now it differs from iOS to iOS. Sometimes in different iOSs he'll use the last one that was assigned. But that really doesn't matter. He has one, he uses one. To avoid this confusion, you have this way of going into the redundant interface and assigning it a MAC address, which will be used by all. Any MAC address that you want. Cannot use this, it becomes a multicast, so it should be 0. It cannot start with 1. Right? So let's try. It'll ping still. But let's try what? For the ARP, what was the reply? 111. Now the redundant interface will always use this MAC address. This is just to avoid the confusion between the physical and the redundant. This is usually when it happens with HSRP or VRRP, what happens is they choose one MAC address which is used by all, right? One guy replies as that MAC address to everybody else. The same is the concept there, but the good thing there was he uses a completely different MAC address, so you know that this belongs to VRRP or HSRP. Here, it's not using a different type MAC address, it's taking a MAC address from one of the interfaces. You have the option of manually giving it a MAC address. So that layer 2 पे जो ये reply करेगा, that reply can be
But
understood.
it can also be used for spoofing.
What?
If it can manually change MAC address.
Yeah, see, you are the network administrator. You're managing what? This, right? So when you do this, then you go to the switch and you do ARP inspection on it. You say from these two interfaces, this MAC address only. You bind the two together. With the ARP access list, you bind this and this MAC address and this IP address. That's your job to do it where? On the switch. Layer 2. I told you, ARP inspection is the best out there. Plus snooping. DHCP snooping. Good? This is your interface redundancy. The second that we have is, second topic for today is ISP level.
Can you combine more than 2 interfaces for one redundant interface?
We can combine up to 8
8.
for each redundant interface.
Same like Ethernet.
Same like Ethernet. It's the same, but see, the thing is, this was a little useless because one interface is down always. So it really doesn't make a difference. I'm wasting a port. Yes, obviously, if one goes down, then I'll save that all that time. If one goes down, the other comes back up again. That's okay. But the problem is I'm still wasting the other interface. So they saw this happening. They also brought in the concepts of port channels in there. Port channeling was also brought forward. But that port channeling is from 8.3 onwards. From iOS 8.3 onwards. They brought in that concept where you can port channel them together. You can port channel it here. You also have to do it on the switch. Supports the same protocols. PAGP, LACP. From both ends. And then it becomes an ether channel. So if there is too much load on one side, it will be going to the other side. At least the link is not wasted. Right? We'll do that when we start our 8.4. With the NATing, we'll also do port channels at that time. Right? For right now, our job is going to be ISP redundancy. What is ISP redundancy? Something like that. I have a firewall have a firewall connected to my inside interface. You might have done this in NANP, CCNA, CCNP, redundancy on the ISP with static routes. Right? It is the same concept, but now on the firewall. So your firewall is connected to the internet usually, right? So you have one connection from Reliance, the other is from Tata. One is 20 Mbps, the other is, this one is only there for the backup, for backup of your very important data, so you don't want to lose connectivity. It's slow, but backup until you fix this side, your internet at least won't go down, and you don't have to pay too much for redundancy. So you can do load balancing obviously over two. These are two different internet connections, right? So what you do is, say this is the router on the internet, this is the router on the internet, this is the ISP's routers, and they are connected to this cloud, which is your internet at the back. Now what happens is, the users are using internet, well, nice and easy. This part goes down. This part goes down. Is the firewall ever going to know it's down from the other side, the link is down? No. The firewall can only know if his own links are down. Then he knows, alright, yes, there's a problem. But the other side, the ISP goes down completely. How does the firewall know? He doesn't. He keeps on forwarding the packets. Your default route obviously will be towards this guy, the better connection. So you're sending packets out here, but they're not being received. They are being dropped where? On the ISP. What was the ideal situation? The ideal situation would have been that the moment it goes down, the firewall makes a switch to Tata. That would have been the ideal situation. Now the question here is, how do we monitor this? How do we make sure that this interface, whenever it goes down, we know that it's down. The firewall knows that it's down. Right?
Using SLM.
Not SNMP. SNMP is done within an organization. This is the ISP, and you are a separate company. You're connected to the ISP, right? We do this by something which is known as.
So, but in real scenario, firewall is connected to a router and then it is connected to ISP.
In that scenario, see, the thing that we are doing right now, SLA monitoring, it's much more better on a router. It's better. Router is better equipped to do this SLA monitoring. But that's not the real life scenario. I told you this also last time. I said it's not very necessary that the router is in the front. Router can be in the front when you're running BGP. If your company is not running BGP, it doesn't make sense to have a router in the front. It makes sense to have a firewall in the front at that time.
Already traffic filtered आना चाहिए ना नेटवर्क के. अगर filtered नहीं आ रहा तो अंदर आने के बाद हम filter कर रहे हैं कुछ बात है.
You understand? It has to. It's again different company, different policies. This feature, this SLA monitoring, if you check the router, much more advanced there. Here is the basic form of SLA, but works properly. It gives you what you want. Right? So let's do this. SLA monitoring. Now what is this SLA monitoring? SLA monitoring is something where we can send probes. I send a probe from an interface. Which interface do I send it out from? So this is outside 2, this is outside 1. Which interface do I use to send the probes? Outside 1. I send probes out from outside 1 towards where? Towards the internet. Which kind of probes? I'll send pings every. Now this every seconds is different for different companies. Again, if you want your internet should be fast, you want to switch quickly, so you can keep it every 3 seconds. But make sure that's extra pings going out of your network. Every 3 seconds, you'll have pings going out your network. You can keep it at 60 seconds. Depending again, the load of your company, the behavior of your company. Can they be okay if the net is down for 1 minute? If you're fine with that, that's okay. Some companies have critical internet connection. They cannot lose it. For them, you can have like 2 seconds, 3 seconds. Yeah? What kind of company? Stock market companies.
Payment gateway.
If they lose 3 seconds, they're losing money. Alright? So, something like that. Now, that's how you configure this part. Then there's also one more feature called timeout. When I send a ping, how long do I wait for it to come back before I declare it dead? How long do I wait? The default is 5 seconds for SLA. 5 seconds, which is a lot. If you ping the internet, now there's no internet right now. If you ping the internet on an actual normal day with good internet connectivity, with even dial-up connection, your internet is going to give you a ping reply of 300 milliseconds on a dial-up connection. 300 milliseconds. So this is a lot. It's huge. 5 seconds is a lot. What you want to do is you want to reduce it. Now, how is it going to help you? It's going to help you in a way that it's also going to make the switch if the internet is going slow. If the internet is slow, your ping will come back slowly. If it doesn't come back, the ping doesn't come back quickly, it considers it dead, makes the switch to the other side. So if your reliance is going more slower than 8 Mbps, maybe 7 or 6 Mbps, you switch to Tata. Then wait for that guy to come back up and go more than 8. When it goes more than 8, 10, come back. Now how do you measure this 8? You ping from Tata, you see the return. You ping from this guy, you see the return. Then you calculate and make the timeout accordingly. According to both. Right? Also, but you'll have to make sure that there's no flapping, so you have to keep that distance also. Otherwise, you'll be flapping from Tata to Reliance, Reliance to Tata, Tata to Reliance. Right? Trying to jump ships. So we don't want that. What do we want? Excuse me.
So what is this flapping actually means?
See, what I was saying right now was that if you want, you can make sure that if Reliance goes less than 8 Mbps, you can move over to Tata. Say you configure the ping timeout to be say 500 milliseconds. You found out from Tata that it gives you 400 milliseconds. It gives you a ping of 400 milliseconds. When this goes to 500, means it's going slow. It's going slow, so you move where? Tata. While you move to Tata, this gets a little faster. When it gets a little faster, the probe will be up again, you'll come back. Then it goes a little slower again. Then you move back to Tata. Comes back again, you come back to Reliance. Right? So doing that will cause problems with your networks. Some sessions will be enabled from here, some sessions will be from here. The reply for this session will come from a different ISP, which won't happen, so you may lose connectivity. So that's why I'm saying, so keep that window also for the flapping when you're configuring it. Okay? Done? Clear? Questions? You understand the timeout, right? So that's, yeah?
It works like PHSRP or
Something like that. Something like that, yeah. But here probes are sent. In the form now, on a router, you can send probes many different ways. You can send it as a telnet packet. You can send it as an HTTP packet. You can send it as many different packets. But here, on the firewall, you can only send it as pings. You can only send these packets as pings.
What about for trace off?
Traceroute Traceroute won't really give you. There may be options. See, when you open the SLA monitoring, there you see a lot of options. A lot of options. Whichever you want to configure, you can. I've never really tried Traceroute because Traceroute by itself is not a packet. It's not a packet. It's a combination of different protocols. So I haven't seen it myself, but if you try to look for it, maybe. But it doesn't make sense to use Traceroute to do that. Yeah, HTTP packet because it's a different type of packet. You send a packet and you wait for the reply of the packet, or telnet packet or anything like that. Traceroute is complex. It sends UDP, waits for ICMP to come back, sends out UDP, waits for ICMP to come back. It's only used for connectivity. The path that Traceroute gives you will not help here. It's only used to check that my connectivity from here to there is possible. Now, why would you use HTTP? You'll say ping is the best I can use. Why would I want to use HTTP? Say, for example, your company, one website is very critical for your company. Say a stockbroking website, everything is done on that website. Or you're a rail booking company, IRCTC is important to you. So that probe that you have will not be a normal ping or to 8.8. It will be a HTTP packet to which website? IRCTC from Reliance. And then you'll monitor that probe. If it goes down, if it slows down, your probe is not going, you'll move over to Tata. You understand? You understand the difference? Yes? Move to configuration.
So if we see there's a fluctuation from the side of ISP, that is speed fluctuation from the ISP side, then how can we do this windowing at that time?
Which windowing?
फ्लैपिंग होगी ना, फिर तो उस केस में तो ऑब्वियसली फ्लैपिंग होगी, क्योंकि अगर उसके तरफ से ही आ रहा है फ्लक्चुएशन तो वो स्पीड एक बार दे दे रहा है कंटिन्यूअसली,
देखो,
थोड़ी देर में ही तुरंत घटा दे रहा है.
Usually जब flapping होती है, whenever flapping occurs, it doesn't happen from 2 Mbps to 15 Mbps, then 15 to 2, 15 to 2, 2 and 15. वैसा नहीं होता है. Usually the speed goes up and down between 3 Mbps. From 6 to it'll reach 8 and come down to 5. So the window will be 5 to 8. ऐसा नहीं होगा कि 5 है, 1 second is 5, the next second is 15, the next second is 2, the next second is 15. No. It'll be somewhere around 5 and 8 or 9 usually. So what you do at that time, उसमें ping का वही window निकालो between 5 and 8 and keep that window. The ping at 5 Mbps and the ping at 9 Mbps. You find the window and then use the upper value of that window to make the shift. Right? If that is actually happening, if 2 to 15 is actually happening, the best thing to do at that time is just remove Reliance. For the time being, जब तक वो ठीक होता है. Right? Moving on to a topology, just like we had. Which ones are my ISPs? R3 and R2. The PIX is the firewall from my company facing the ISPs. Right? So PIX is facing 2 from 2, 3 from 3, and 1 from 1. Good. This is what? 30.0. Now, this is an internet connection. This is not 192.168, this is 192.1. And this is internal, so .0. This is
R4 is cloud.
R4 is the cloud. These are different ISPs connecting to the cloud. So the IP for you is different from both ends.
So why you use always PIX, not ASA?
ASA is heavy, it causes problems. स्लो हो जाता है ना बहुत. This is quick, starts up quickly, and there's not much difference. There's no difference at all to configure. कोई फ़र्क लगी क्या आपको? It's nothing. Simple. It boots up quickly, it reloads quickly. उसमें reload भी नहीं होता अच्छे से. फिर it doesn't come back up. Shut it out once, it doesn't come back up. I want to change my symbol. So this is the cloud. This is ISP1. This is ISP2. ISP1. ISP3 नाम देता हूँ इसको. I just call it 2. Good. This is inside. Everything is well end. Good. Let's make our router talk. What is the address on R1? 10.11.11, and a default route pointing towards the PICs. Good. R2 is my ISP1. This is the internet connection pointing towards the PICs. This is the other connection pointing towards 24, towards R4. Right? Right? I'll also run EIGRP here. Why EIGRP? Now ideally I should be running which protocol here? BGP. Because this is the internet, all the routes on the internet are shared via BGP. I will not run BGP, the only reason being it's slow. That's the only reason. 30.0, network 150.1, 34.0, no auto interface, FA00, IP address. One dot 34 dot. Also have a default route towards where? 34 dot, not the PICs. This is the internet. I don't really need a default route since I'm running EIGRP. So no need for the default route. Finally R4. EIGRP 10, network 150.1.0.0. No auto. Interface FA00. Now hopefully interface FA00 is the left one. Yeah. So FA00 and 0, 1. Interface FA00, IP address 150.1.24.4. One dot 34.4. Right? Let's ping 24.2. Good. 34.3. So the routers are connecting, talking. EIGRP should be up or no? Sup. Sup show IP route. I have the routes, which one? 30 and 20. This should be there. Why? Because this is the ISP, the internet. So this route should also be known by the internet. This route should also be known by the internet because these are public addresses. So all my public addresses from here are shared. This will never be because this is a private address. So for R1 to go out, he should use what? He should use a He should do NATing. R1 should use NATing to go out, otherwise he will never be able to access the internet. On R4, what I'll do is also create a loop back with the address of, or better yet, A.8, just like it's Google, the DNS server, right? Who can reach this right now? The PIX can, should be able to. After I configure it.
EIGRP को भी
No, cannot run EIGRP on this. हाँ
hardcore.
चलाए ना ये
तो
लूप बैक को एडवर्टाइज करना है. यस ट्रू. On R4 router EIGRP 10 network automatically 8.0 हो जाएगा. Interface Ethernet 1. Which one is Ethernet 1? Pointing towards R1. 11.10. No shut. Name if inside. So inside is towards R1. Then now this is the tricky part. This I'll choose as outside 1. This I'll choose as outside 2. Outside R and outside T. So I'll say interface Ethernet 2, security level 0, no shut, name if, outside R, IP address is 20.10. Good. Interface Ethernet 3, security level is 0, no shut, name if, outside, IP address is 30.10. Good. Show name if. Can I ping? Not 4.4. 20.2 I can ping. 30.3 I can ping. And 10.11 should also be pingable. The question right now is, can I reach the internet? Can I reach 8.8? Why not? I don't have the routes. So what do I need to go to the internet? What kind of a route? A default route. A default route to go to the internet. Right? Let's do that. I'll say route outside R. Where do I want to go? 0, 0. The next hop is what? 20.2. If I do this, outside T, 0, 0, will it take the command? It will not take the command. It tells you cannot add the entry because of conflict. What am I trying to do? I'm trying to go here and tell him one default route towards this side, one default route towards this side. So you cannot have two default routes. You'll be confused what to do. Some packets will go that way, some packets will go this way. Not allowed on a firewall. In that case, what you do is, you make the other one, no problem, but give it an AD of more than one. So that will be used as a backup. In case this gets removed, the first one gets removed from the table, the other one, data will be used as the backup, which is good. Show route. I have a route. Can I ping now? 8.8.8.8. I can ping. The firewall can reach 8.8. Let me do this. Let me go on R4. Right? Now from R1. R1 cannot right now. I need a mapping. I'll say global outside what? Outside R. 10 192.1.20 dot 20 dot say 50 to 100. NAT inside to what? 10 0, or I'll say 10 11 11 0, right? I'm natting my this networks to come on where? To use this address. Let's see if it works. Telnet what? 8.8.8. Cisco show users. I'm getting out as what? 192.1.20.50. Clear? Clear? Understandable, right? It's easy. I'm going out using which interface?
सर ये जो अभी आपने
Yes.
NAT tool बताया है, you have created this only for Reliance.
Only for Reliance.
So like if Reliance we have to
Create a
another
different pool for this.
Tata.
That'll be a different interface. वो अलग से बना access list से भी कर सकते हो, but वैसे भी कर सकते हो. You can just do this.
Because
You can
different
say
ISP will be providing different pools.
global outside T, उसका नाम different दिया 20, 30.50 to 30.100. Then NAT inside 20 भी किया 0 0. That's okay, it'll work. So when he's going this interface, he'll use this side. When he's going this interface bind हो रही है ना, global outside and global this. So that'll be bound. Right? Right now that's not my case. My case is when this interface goes down here, does it make the switch or not? Will it make the switch? If it goes down on the PICs, if it goes down on the PICs, will it go here?
Yes, on the picture.
On the PICs it should go, because if it goes down on the PICs, it will be removed from the table. If it's removed from the routing table, the other one will be inserted back. Let's try. On the PICs, interface, Ethernet 2, shut. Shut. Show route. I still have a default route, but now from T. Now from T. From Tata. Can R1 still reach? Connection refused. It's going. Why not? No matching global. Did I not create a global? I did create a global saying 10. I also did that. If I telnet, it's cannot telnet. From here it works, from here it doesn't. Obviously ping will not work anyways. How about here? 30.3. Also refused. So the PIX is refusing him because he's not able to translate. Let's do one thing. Static inside 2, outside T, saying 10, 11, 11, no, 30.100. See if it works this way.
पासवर्ड तो सर दिया होगा।
नहीं 8.8 पे दिया ना.
Okay.
Show users works, right? So there's something wrong with the pools. Let's fix that. इसको remove करते हैं. Show run NAT. ग्लोबल तो ठीक है. Yes. Inside में क्या problem है? No, when he's going from the other side, it's going properly. He's not able to go from here to here. He's not able to find the mapping for 10. So I'll create another one then. No, clear config. Cannot clear the whole thing, so I'll just remove this. Oh yeah. 20 is 0 0, right? Yeah. What I'll say is, अब क्या है command? Show run nat. 10 निकाला मैंने. Show run global. सभी हटा देते हैं, नए से बनाते हैं. Let's create for the first one first. पहले इसके लिए बनाते हैं. Outside T के लिए बनाते हैं पहले. I'll say 10 192.1.30.50 to 30.100, right? Nat inside, move it to 10 0 0. This should work. All of them. This works, right? Then I'll create another one. Now this should work. This has a problem. Global outside R 11 192.1.20.50 to 20.100, right? Then nat inside 11, right? 0 0. Duplicate nat entry. So you have to be specific about it. You have to be specific. That's why it was not happening before. You have to be specific and tell him specifically that, listen, this guy is gonna come. Let's try again. But first, interface Ethernet 1 को बंद किया था ना, 2 को. No shut. 2 is back. Now it goes. Source क्या use कर रहा है? 20.50. Using 20.50 because he's going this way. This is Reliance. This is Reliance. A better way to do it would also be static inside, outside R, right? 10, no, 192.1.20 dot, say 50 for 10, 11, 11, 1. And this is R, right? From T, what should be the address? 30.50. Of the same inside, 30.50 from, if he's coming out from Reliance, 20.50 if it's coming out from, sorry, from Reliance, 20.50, from Tata, 30.50. Right? So, right now, my interface redundancy is set up, but it's not on ISP's level. What do I mean by it's not on ISP's level? Right now, see, when I shut down the device, yes, it works. Interface Ethernet 2, when I shut it down, yes, it works. It does move to dot 3. My communication is still successful. I'm going out using a different interface to get out. That is happening, but the problem is this. Say, alright, this comes back up. Ethernet 2, no shut. Comes back up. Communication still works. No problems. But the problem is if the ISPs, this interface, F00, interface FA00, this goes down. The ISP is down, and that happens a lot. Happens a lot, it has happened a lot. Right? And as the internet was down for what? A month. Right? It happens. a lot of times. So what do we do in this case? How do we make the shift? If we make the shift, see, right now if he's trying to go now, he will never reach. Because there's no one stopping him. Firewall thinks it's okay. Firewall thinks the route is fine. Forwards it out. Goes to the ISP. R2 drops it. R2 is the ISP. He doesn't care. He doesn't have an SLA with you. Right? To prevent this problem. Let me bring it up again first. No shot. To prevent this problem, we have something called SLA. We can do this on the firewall. You have to enable this on the firewall. How do you do it? Go to the firewall. You say SLA monitor. Then give it a number. You'll probably have seen this number a lot of times before. 122.147.4.8.3.6.4.7. That's a huge number, so you can have any number that you want. Just like loopbacks, just like virtual interfaces. I'll choose 10. Then enter. See, the good thing about this is use question mark, it'll help you along. There's only one option. What? Type, echo, protocol, IP, ICMPA, and then the address. What does it mean? The type of probe that I'm going to send is going to be which type? Echo. It's going to be echo. If I specify echo, why do I have to specify ICMP also at the same time? Because echo can also be a UDP echo, it can also be a TCP. So you have to specify this echo is IP echo, IP ICMP echo. Right? But there's not many options that you have here. It supports ICMP. There's only one that it supports. Where do I want to ping? What is the address that this probe wants to ping? 8. Type echo, protocol, IPSCMP echo, and the address that I'm going to ping is the internet. I'm going to ping the internet, but from which interface? Outside R, because that's the one which I want to check. From that interface, I'm going to be sending this probe out and checking if I get a reply back or not. If I get a reply back, well and good. The SLA is up. The result is okay, that's all. The SLA is not bound to anything. Remember this. SLA will only give you a state, okay or not okay. That's all it does. You cannot bind it anyway. We'll see how to bind it although. Done? Echo is created, then you have more options. From this, the important one is frequency. By default, it's 60 seconds. The probe is sent every 60 seconds. If you want, you can reduce it to 3 seconds.
Can it go less than?
You can go as much as 1 second. Right? So 3 is good enough. Then timeout. See, what does it say? It cannot be less than timeout. What is the timeout that you have? 5. So now you set the frequency to 3. The timeout is 5. That means he waits 5 seconds for a ping. That's why he says I cannot send within 3 seconds while I'm still waiting for the last one. So either reduce the timeout or increase the frequency. I'll reduce the timeout. Reduce the timeout to, I think 1000 is okay. 1000 milliseconds is more than enough for good internet connectivity. Right? And then we have frequency, which will be 3. Done? You can also have number of packets. I want to send how many packets? Usually it sends 1. I'll send 3 packets at one time. Why do I send 3? Maybe sometimes what happens is one packet does drop because of something else. Maybe there's a drop, maybe there's congestion in the network. There's a QoS policy. Something, whatever way it happens, the packet does drop. What do you do in that case? I'll send 3. So then he'll take the average. If he gets 2 replies back, then it's okay. He knows that 1 has dropped. But again, you're doing this according to your company's needs. If your company does not have that much higher requirement for security, for internet, but you configure it like that, you're wasting packets. Every 3 seconds you're sending 3 packets. But yeah, if it's critical, if the internet connection is critical, then you can pay this price. Good? Let's do that.
Send 3 packets in 3 seconds. Then what is the minimum criteria that it would not shift? Only 1 packet gets back. That would be fine.
If all 3 drop,
Okay. Even 1 gets back, it will not.
it won't. If he gets a reply back, then it's fine. Then he'll wait for the other one. Right? That's done. I have created my monitor. I need to turn it on. Not apply it, I need to turn it on. It's not sending the probes right now. Let's go where? Let's do what? Let's have a look at the probes. See how they look like. Right now there's nothing, just EIGRP packets going through. To turn on the probe, you have to say SLA monitor. Then you have 2 options, right? First I set the number. Right now I don't say the number, I say schedule. When? The entry number. Which entry number do you want to schedule? 10. When? Start time. Start time? Now. Lifetime? Forever. Start the SLA now. The life is, check this out. It's just a normal ping. It's nothing else. It's just a normal ping. 3 packets going out, 3 packets coming in. 3 packets going out, 3 packets coming in. It's checking for the reply. Right? It's being sent what? Every 3 seconds. How do you check? What is your return code? Show SLA monitor operational state. Operational state. What is the code? If the code is okay, you're fine. If the code is okay, you're fine. Packets are being sent here. The reply is being received here. I have the probe. I have the answer which says that it's okay. I cannot bind it. There is no ruling which can bind your SLA to something else. SLA, to bind an SLA to something, you need a different object. Now SLA is here, he's sending the probes. You need a different object here, which is called a track. The answer that you get from the SLA, you put it in the track. The track can be bound to an interface or anywhere, wherever you want it to. So first things first, I got this, right? I have the SLA answer. I'll have to create a, how do I do that? I'll go here, it's called track. Now this number has no significance to the number that we had before. There I used 10, here I can use 100. This has no significance, it's a new object. I told you these are 2 different objects. SLA is a different object, tracking is a different object. In tracking, you call the answer of your SLA. Okay? Let's call it. Let's see how to call the answer. How? Response time, responder. RTR. RTR is used to call your SLA. RTR here in tracking language means SLA. Right? Response time, reporter. My reporter is, what is the reporter number? He's going to get the report from which object? The other object, which is RTR. RTR means SLA and 10. The number is 10. Reachability. Check it for reachability. Return code status. Reachability. Is it okay or not? If it's not okay, track will also not be okay. This is all that matters. Reachability is up. If reachability goes down, track will go down. Now think of it like a box. Think of track like a box. This box I will attach where? to my default route. To my default route. If the value of the box is okay, the default route is valid. If the value of the box is not okay, the default route is not valid. We had a similar characteristics we used earlier sometime. Do you remember what it was? In access lists, there's a kind of access list which does this. Time-based. Time-based access list had a time range. If the time range existed, the access list was valid. Time range goes away, the access list was not valid. It's a similar thing here. The return code is okay, the route is valid. The return code is not okay, the route is not valid. In short form, if the probe is missing, the route will not be valid and the other one will come up. Let's check. I had this route outside R, right? Reliance, which was pointing towards 20.2, right? I'll remove it. What is my route now? Is using 30.3. But remember, the administrative distance of 30.3 is 10, right? It's 10. I'll create another outside R using the same thing, same values, but I'll bind it to what? Track. What was the number of the track? I'm binding it to 100. What is the return code right now? Okay. So the route should be valid right now. My traffic should go from where? Should go from this side. From 20.5, 50. Right? But the moment the reachability goes down, it should move over. Now reachability can get down anywhere. It can get down on the ISP anywhere. On R2, I won't do it on this interface, I'll do it on this interface now, which is not even facing you. Let's go. Interface FA01, shut. It was not facing you, remember? Let's see if this guy can go. Not yet, but yes. 30.50. It made the shift. Let's see if it can come back when it comes back up again. What happens when it comes back up again? Does it go back? Will it go back? Think about it. Think about it. When I do no shut here, what happens? What happens to the probe? When the interface is down, the probes are still being sent every 3 seconds. But they're just not reaching. So the return code is not okay. But the moment this comes back up again, the probes will reach the destination. The return code will get okay. If the return code goes okay, the route will become valid. If it comes valid, its administrative distance is better than the other one. So it becomes active and it becomes the default gateway. Yes? Understand? Even if the return is slow, remember, even if the return is coming slow, if it's slower than 1000, if it's coming back at 2000, it'll still make the shift to the other side. Because it will not wait for more than 1000 seconds, it'll shift. Let's do one more thing. I want to see how long does it take to shift. Access list, INF, permit, ICMP, any. Access group, INF, in interface, outside R and outside T. Permitting ICMPs to come back. This should work. Right? I'll go to R2 again and shut. Count the seconds. 1, 2, 3, 4. 3 seconds and then the shift. Right? So for some time it says unreachable. then it moves on to the other side. Who says unreachable? R2. R2 is sending a message back saying it's unreachable to you. But it shifts to the other side. Good? That is ISP level of redundancy.
Sir, I have a question like in this SLN monitoring, you are taking 8.8.8. Why we are not taking our the interface of our ISP?
The interface of ISP?
Because like if some problem happens, this and ISP is also taking bandwidth or the facility from some other higher level ISP. Later if we claim, definitely this is the purpose of SLAs, later we will claim you are not providing us services,
Definitely.
you breach the SLA.
Definitely.
Then what will happen, he will say "Ki I was not getting the speed or the problem was from behind, from up. So why we are not saying that was it his fault or the definitely there was some
See, it matters on what you want to do. If you're doing it on this, usually what happens is your connectivity to the ISP is okay. What if the ISP loses connectivity to the internet from this side? What if this link breaks? Your job is important that you should have full reachability to your device. I'm doing it for 8.8 just to show you.
The ISP can say that is not a problem because the problem is from the higher end.
See, it depends. Again, what I'm saying is it depends on the company you're working for. Your job is that your company should go to IRCTC. It does not matter if, see, the ISP is doing that. The ISP is, right? But does that mean that you'll stop your business? What is more important to you? To do your business or that SLA that the ISP should not charge you more? Two things, right? If it's more important for you that this site should remain up 24/7, then you'll check your reachability until the website, complete website. If the SLA is more important to you, that the ISP should not tomorrow tell me that you're breaking, the problem was from the other end, then you check it until the ISP. So which one is more important to you, right? That's why I did it on 8.8. I just wanted to show you an example that I'm doing it to 8.8. It doesn't necessarily have to be 8.8. Can be any stockbroking website, which everyone in your company uses, right? Is this clear? The last thing that we have to do is failover. Now we move to the real stuff on the firewall. Failover. Right, but we'll create a separate video for this.